All right, buckle up, ladies and gentlemen. We got a new type of linear equations we're dealing with today. These are linear equations with x on both sides. So in other words, we're going to be looking at equations where x isn't just on one side. We've been looking at this whole time where we say, oh, we got to get x all by itself. We're going to look at linear equations where there's x on both sides of the equation, and you got to move them all over. Woo, here we go. So here's today's plan. We're going to review a few word problems, and then we're going to investigate cases where we have x on both sides of an equation, like I was just hyping up there. And then we'll get some practice. All right, anyway, here we go. So here's a word problem. First things first, Brooke earned 4/6 of the profits of running a snack stand at a basketball game. Her earnings were $160. So in other words, that's what she was able to take home. What was the total profit of the snack stand? Okay, so again, Brooke earned 4/6 of those profits and her earnings were 160 bucks. Pause the video here, see if you can come up with an expression and see if you can solve this. All right, so I'm going to go over this. Remember, the age-old trick behind dealing with these is this word of right here. In math, when you see the word of, especially when it's of something, that's a pretty good indication that you're going to be multiplying. So 4/6 multiplied by the profits. Now, that amount is what she's earning, right? So 4/6 of the profits is what Brooke earned. So let's say x equals the profit. Right? So this is how much profit that snack stand actually made. So 4/6 of the profit, so 4/6 x equals Brooke's earnings, which we know was $160. To get x all by itself, we need to divide both sides by 4/6. But we encounter a little bit of a problem on that right-hand side now because we have something divided by a fraction. You can consider 160 its own fraction if you put it over 1, so a fraction divided by a fraction. That means we need to keep change flip. So this is going to become x equals 160 over 1. That's the keep, change to times, and then flip this to be 6 over 4. This is going to become x equals 160 times 6, which is 960, over 1 times 4, which is 4. And then, of course, we can simplify this down just by going 960 divided by 4. And you're going to see that x, which represents the profit, equals $240. So in other words, the total profit of that snack stand was $240, and Brooke was allowed to earn 4/6 of that profit. Cool. Anyway, moving on. Next word problem. Aaron has 3 times as many nickels as dimes and 4 times as many pennies as nickels. This is the first time we've ever thrown in 3 different kinds of coins here. He's got nickels, he's got dimes, and he's got pennies. Holy Toledo. Now, if he has $1.85, that's $1.85 in total, we're assuming, how many of each coin does he have? Before I get you to pause the video here, let me remind you the strategy behind this. You need to figure out, of course, from the question, the value of each coin and multiply it by some sort of expression using an x to represent how many of those coins you have. Even though we have 3 different kinds of coins here, you can still all base it around an x, where x represents one of these 3 kinds of coins. Anyway, pause the video here, see if you can figure this one out. I'll go over it in just a second. Okay, so my trick behind this is find the coin that everything can kind of relate back to. We know we have 3 times as many nickels as dimes and 4 times as many pennies as nickels. Now, in reference for pennies to nickels, we know nickels themselves are already 3 times as many as dimes. So I think our lowest amount of coins here is going to be dimes. So let's say let x equal the number of dimes. And then we know we have 3 times as many nickels as dimes. So then therefore we can say 3x equals the number of nickels. And then here's what's weird. We have 4 times as many pennies as nickels. Well, the number of nickels we have is 3x. So we need to take 3x and we need to multiply that by 4 for an expression for how many pennies we have. So 4 times 3x equals the number of pennies. But there's something we can do even better than that. 4 times 3x is 12x. So 12x actually represents the number of pennies that we have. Okay, so again, x represents the number of dimes, and we have 3 times as many nickels as dimes, so 3x represents the number of nickels. And then we have 4 times as many pennies as nickels, so 4 times 3x, which is 12x, that represents the number of pennies we have. So if you wanted to really relate this all back, you could say the number of pennies we have is 12 times as many dimes we have. Okay. Now we know Aaron in total has $1.85. Okay. So how we get to this is we assign the value of each coin and multiply that value by the number of coins we have. Let's start with dimes. We know a dime is worth 10 cents. So we'll say 10 cents times the number of dimes, which is X, plus the nickels, which is 5 cents, of course, so 0.05, times the number of nickels, which is 3x, plus pennies, which is, of course, 1 cent, 0.01, times the number of pennies we have, which is 12x. And this in total is going to equal $1.85. Just to break this down a little further for you, this 0.10x represents the total value of the dimes, because it's 10 cents, the value of a single dime, times X, which represents the number of dimes. So this is the total value of all of our dimes, all added together. This thing right here is the total value of our nickels, right? Because it's 5 cents multiplied by the number of nickels we have. This, of course, represents the value of the total number of pennies we have. So in other words, all of our pennies added together gives us this overall value, 1 cent times 12x pennies. So if X was 1, if we only had 1 dime here, then that means we would have 12 times 1, so we'd have 12 pennies, which would be worth 12 times 0.1, so 12 cents, right? Hopefully that makes some sense. Sense. Anyway, so let's now try this one. We got to combine all of our like terms here. So I'm going to multiply this through. This is going to become 0.10x, that one didn't change, plus this multiplied in here is going to be 0.15x, plus this multiplied in here is 0.12x, and all of that added together is $1.85. Now that we've done this, now that we've multiplied it all through, we can see we have like terms. So we can add all of our like terms here together. 0.10x plus 0.15x plus 0.12x. If you add those coefficients all together, you're going to get 0.37x equals 1.85. To solve for x, we just need now to divide by 0.37. So if you divide by 0.37 on both sides, I'm pretty sure it's going to be 5, but let me just double check. Yep, it's going to be 5. So x is going to equal 5. Now it's really, really clear. We make our answers perfectly crystal clear on this one. X is equal to 5. Let's remind ourselves what x represents. X represents the number of dimes we have. So in other words, Aaron here, he's got 5 dimes. Now we need to figure out how many nickels he has. Well, 3x is the number of nickels. If x was 5, then that would mean 15 is the number of nickels he has. I'm just trying to write this in so it's still readable. So 15 is the number of nickels. And then, of course, the number of pennies he has is 4 times as many as he had nickels. So nickels, he's got 15. So 15 times 4 is 60. So he's actually got 60 pennies in total here. Holy Toledo, right? Now, if you're ever not sure if you got this question right, you can like add all this up by plugging it back into your original equation, or you can even just think about it logically, right? 5 dimes, that's going to be worth 50 cents. Okay, so 50 cents plus 15 nickels, which is 15 times 5 cents, which I think is 75 cents. So in other words, 50 plus 75 cents, that's $1.25, plus 60 pennies, which is only 60 cents. So $1.25 plus 60 cents, yeah, that's $1.85, right? So it did work. You can check it just by thinking about what that all that is added together. All right, so here's the new stuff for today. Solving equations with x on both sides. To solve these, we want to get all the x's on one side, right? So in other words, we want to go back to what we already know. And still, it's just all a matter of reverse BEDMAS. So it's all a matter of getting rid of what you have in this addition and subtraction end first and working your way towards brackets. So again, the main goal here is get all your x's gathered on one side. So if I look at this very first question, 5x equals 2x plus 9. We got x over here, and we got x over here, right? So there's x on both sides of this equation. It's crazy. But we want to get all the x's to one side. So what I usually do is I look at the smaller x, and that's the one I move over first. So let's say this 2x, let's move it over to the other side. And to do that, we just have to do the opposite operation. Technically, this is a positive 2x right here. So to get rid of that, let's minus 2x from both sides. That gets rid of it on the right-hand side. And on the left-hand side, we have 5x minus 2x. So we've only got 3x left over, and that equals positive 9. Now to get x totally by itself, this becomes a lot more familiar. We just need to divide by 3 on both sides. And this is going to give us x equals 9 divided by 3, which of course is just 3. Not really any different than what we've been doing this whole time, right? So when there's x on both sides of an equation, just gather them to one side of an equation and then go from there. Anyway, let's look at some more challenging ones here. If you're feeling really bold, you can pause the video here and do these on your own, but I don't expect it. But if you'd like to, go for it. And for the rest of us, including the ones who just came back, let's go over this now. So bring all of your x's to one side of an equation. Again, I like focusing in on the smaller x because it just makes my life a little bit easier. So since I got 7x over here and 3x over here, let's move the 3x over, right? So let's minus 3x from both sides. Whatever you do to one side of an equation, you have to do to the other, because otherwise your equation isn't going to be balanced. So when I minus 3x from both sides, that just leaves me with 4x on this side. So it's 4x plus 10 equals 20. This becomes a two-step problem from here on. So I guess really we could say this original thing was a three-step problem. But this becomes a more typical two-step problem, just reverse BEDMAS it. So in other words, let's get rid of this plus 10 because we want to get x totally by itself. So let's minus 10 from both sides. This gives us 4x equals 20 minus 10 is 10. And then divide by 4 on both sides, and you're going to have x is equal to 10 over 4, which I would accept as an answer, sort of. You can actually reduce that. You can say it's x equals 5 over 2. That's a better answer. But really, in this situation, 5 divided by 2, like, come on, guys, it's just 2.5, right? So in other words, that works just fine as an answer as well. Whatever floats your boat. All right, this next one, here's where something weird kind of happens. In the past, in previous examples we've done with brackets problems, I've always been like, oh, you know, the number just on the outside of the brackets, just divide it away, just get it like divided on both sides. That wouldn't be a reasonable strategy here. And here's why. If you're going to divide 5 away first, you would have to divide this thing and this thing by 5, which would be great if both of these numbers divided by 5, really nice, but 2 doesn't divide by 5 and 21 doesn't divide by 5. So let's not do that. Instead, on this question, I'm going to take this 5 and I'm going to double dip it through the brackets here. And you're going to see why that's a benefit in just a second. If I double dip it through the brackets, I'm just expanding this out. I'm not changing what it's equal to. It's just expanding it to write it a different way. That gives 5x plus 5 times 3, which is 15. That equals 2x plus 21. Now that it's written like this, it looks a lot more like this one we started with. So let's minus 2x from both sides because we want to move the smaller x over. And that's going to leave us with 3x plus 15 equals positive 21. Now this becomes a two-step problem, kind of like what we had right here. So let's minus 15 from both sides. This is going to give us 3x equals 21 minus 15, which is 6. And then just divide by 3 on both sides. That's going to be x equals 2. So again, really not a lot different from what we've already done. Just a few little tricks come in here and there, and multiplying it through just basically allowed us to do things just like we've been used to. If you weren't able to see that right away, you can always just play around with it. Math is one of those things, as long as you follow the rules, you shouldn't ideally end up anywhere that you shouldn't, right? So if you tried dividing by 5 on both sides, as long as you're remembering, well, I got to divide everything by 5, you'd actually end up just fine. You just have some weird decimal numbers that you'd be dealing with, and maybe that's not so ideal. Okay, here's some really scary looking examples, but let's not panic for a second here. First one is 1/2 x plus 1/2 equals 3 over 4x. Well, let's keep my rule in mind. I always like moving my smaller amount of x over to the other side before I even begin. Between 1/2 x and 3/4 x, 1/2 is the smaller one. So you know what? Let's move 1/2 x over to the other side by minusing 1/2 x from both sides. So here's another issue though, 3/4 x minus 1/2 x. You can consider that like amounts of x. So you're just going to subtract the coefficients. So 3/4 minus 1/2. But you can't do that unless they have a common denominator. So here's what we got. We've got 1/2, that's this guy, equals 3/4 x minus, instead of writing this as 1/2 x, I'm going to write this as 2/4. So 2 over 4 x. That's now going to give me 1/2 equals 3/4 x minus 2/4 x. That just leaves us with 1/4 x. And now we want to get x totally by itself, so we just need to divide by 1/4 on both sides. But watch out, we have a fraction divided by a fraction. Hopefully by now you can see it's going to be a keep, change, flip kind of a question. So 1/2 times 4/1, that's the same thing as 1/2 divided by 1/4. And that's going to give you 4/2 equals x. But 4/2 simplifies to something even nicer. Look at us go. It's going to be x equals 4 divided by 2, which is just 2. Awesome. Real interesting, I know. All right, here's another question. This one also looks quite challenging. A couple different ways you could go about this, but of course, since x is on both sides and they're both locked away in brackets, I think this might be one of those questions where you'll actually want to double dip things through. If you didn't double dip things through, there's other ways you can go about it, but you know what? Let's not worry about that. Let's just double dip things through. So this 1/3 has to double dip through here, and this 1/4 has to double dip through here. So if 1/3 is multiplying each of these, that's going to give us 1/3 times x, which is 1/3 x, plus 1/3 times 2, which is 2/3. And that's going to equal 1/4 times x, which is 1/4 x. And then 1/4 times 4, which is 4/4. Or in other words, just 1, right? Because if you have 4 times a quarter, 4 quarters is 1 whole, right? Anyway, we'll just leave this as 4/4 for now. Next up, we want to move our smaller x over to the other side. Well, between 1/3 x and 1/4 x, 1/4 x is the smaller one, so let's move that one over. But once again, kind of like the last question, when we subtract these two, oh, why did I say divide? My mistake, sorry. Subtract 1/4 x. When we subtract these two, we need to have a common denominator. So between 1/3 and 1/4, a common denominator is going to have to be 12. So just to save us a little bit of room, I'm going to do that all in one go. 1/3 x can be written as 4/12x minus 1/4 x could be written as 3/12x. So 1/3x is 4/12x, and 1/4x is 3/12x. Okay, plus 2/3. That was this guy that was just chilling. Equals, this is gone, so equals 4/4. You know what? Now I think I'll just commit. We'll just say it's equal to 1, right? Because 4/4 is 1. Let's clean this up even more. 4/12 x minus 3/12 x, that's just going to be 1/12 x. Let me just divide this so we have a little bit more room. So 1/12 x minus, or sorry, plus 2/3 equals 1. I think the next thing we probably want to do, because this is something times x plus 2/3 with reverse BEDMAS, that would tell us we need to move this 2/3 over. So let's minus 2/3 from both sides. And that gives us 1/12x equals 1 minus 2/3. We'll think of it as 3. You know, I'm just going to erase this here. Think of it as 3/3 because that's 1. It's 3/3 minus 2/3. That's going to leave us with 1/3. And then to get x all by itself, we just need to divide by 1/12 on both sides. And once again, to save us some room here, remember when we're dividing two fractions, we can write that as keep, change, flip. So that gives us 12, that's these two, 12/3, which simplifies very nice to x equals 12 divided by 3, which is 4. Whew. Okay, that was a long question. These fraction kinds of questions will just drive you up the wall. That's really where most of the beef is on this one. But still, you got to be prepared for it. They do come around. And speaking of being prepared for something, woo, looks like meat's back on the menu, boys and girls. Then we got a challenge question. Woo, who let the dogs out here? So this looks absolutely terrifying. This is an absolute nightmare question. But if you can believe me, going back to this other one, it's actually very similar to that one. That second question we just did there. It's just got some more fractions in there. This thing is a nightmare. This thing is the stuff that keeps little children awake at night. Holy smokes. Anyway, let's challenge this one. Let's defeat this beast of a question right here. If we're going to solve this, I think it would be best to multiply our fractions through the brackets, because notice it's -2/3 times, right? Technically a times there, x minus 4/3. So we can double dip this through. Like imagine if this was just like a 4 here or something, right? It would double dip its way through and you'd be good to go. Same with this 5/2, it can double dip its way through. Let's see where this leads us. This is going to give us negative 2 over 3x minus negative 2 times 4, which is negative 8. So minus negative 8 over 3 times 3, which is 9. That's already cleaned up a little bit. Equals 5 over 2 times x is just 5 over 2x plus 5 times 2, which is 10, over 2 times 7, which is 14. Okay, so this is already pretty crazy, but we want to gather all of our x's to one side. Now, by the looks of it, my quote unquote smaller x here is going to be this guy because it's a negative 2/3 x. To move over a negative 2/3 x, think of this as like minus 2/3 x. Let's add 2/3 x to both sides. That's going to give me minus negative 8 over 9. Let's not mess around here. When you're minusing a negative, that can just become positive 8 over 9 equals 5 over 2x plus 2 over 3x plus 10 over 14. Now, just to save me some room here, I'm going to kind of like cheat at this a little bit. Between 5 over 2x and 2 over 3x, if we're going to add these together, we just have to add these coefficients together. So 5 over 2 plus 2 over 3, but they're fractions. So we need to have a common denominator. Just to save some room here, I think we can see that a common denominator between 5 over 2 and 2 over 3 would be 6. So if you multiply this first one by 3, you're going to get 15 over 6. And if you multiply this other one by 2, you're going to get 4 over 6. So we have 5 over 6x plus 4 over 6x. This is going to give us 8 over 9 equals 19 over 6x plus 10 over 14. Oh boy, I'm seeing this one's even worse as time goes on. Oh my goodness. All right, so to get x all by itself, we got to minus the 10 over 14 from both sides. Oh no. All right, so we're going to minus 10 over 14 from both sides. That gets rid of it here, but then we got to move it over here, minus 10 over 14. Once again, you can only add these two together if they have a common denominator. Well, between 9 and 14, it's pretty hard to think of a common denominator that's going to work there. Like off the top of my head, I'm not thinking of any that are even reasonably low. I think maybe, no, I was going to say 56, but no, that doesn't actually work. I think we're going to have to do the best we can on this one. When we have 8 over 9 minus 10 over 14 equals 19 over 6x, I think the best we can do here is just multiply each of these fractions by the other one's denominator. That's the strategy that works 100% of the time. That is the way of forcing two denominators to look the same. So again, if we take this 8 over 9 and we multiply the top and the bottom by 14, and if we take this 10 over 14 and multiply the top and the bottom by 9, the other one's denominator, this is going to give you on the top 14 times 8, which is 112, over 14 times 9, which is 126. So 126 is going to be our common denominator here. Look at us go. Minus 10 times 9, that one's not bad. That's 90 over 126. And that equals 19 over 6x. Oh, geez. All right. So anyway, 112 minus 90, that's going to equal 22. So we have 22 over 126 equals 19 over 6x. Okay, so last but not least here, we need to divide this 19 over 6 away. The more I look at this question, the more I'm thinking, why on earth did I put this in here? You guys are like just going to have nightmares about this. 22 over 126 divided by 19 over 6, that's a keep change flip. So this is going to become, oh, and this is gone over here now. So keep change flip, this is going to be keep 22 over 126, change to a times, flip to 6 over 19 equals x. 22 times 6 is 132 over 126 times 19. I'm kind of afraid to ask, is 2,394. That equals x. Honestly, if I ever were crazy enough, I'm just going to erase this. If I were ever crazy enough to ask you this question, I would accept that as a totally fine and perfectly valid final answer. But if you are going to simplify this, let's see what this actually could simplify to. I could divide both the top and the bottom I'm pretty sure by 6. If I go 132 divided by 6, that's actually going to give me x equals 22 over 2,394 divided by 6. Yep, that one worked. That's going to give me 399. And I really don't think anything else divides there. The bottom could divide by 3. This guy on the top couldn't divide by 3. The only things the top could divide by are 2, which the bottom one can't, and 11, which, just checking, the bottom one can't. So 22 over 399 is the answer there. What the heck? Why am I even asking a question like this? That's insane. So as much as we just spent like 5 minutes going over this question, rest assured, guys, I will not ask you anything this challenging. Something that might be as challenging as I'll ask you might be that second question on the last slide. That's about as hard as we can ask. This is absolutely insane. That is just stupid. That's just like dummy hard right there. That is just insane. So no, I won't be asking anything like that. So don't worry. But hey, you know what? The journey is the destination. Isn't that beautiful? Look what we did there. We should be proud of ourselves. Yeah. All right. Anyway, so for practice, page 327, questions 6 to 15. This is a new selection of questions today. That's a lot of questions in there. See what you can do. If you don't get through them all today, that's all right. Anyway, you know where to find me. Best of luck.